Hello children. In the last video we have seen about mirrors and image formations and where and all we use that particular concave mirrors and convex mirrors, and we have studied about what are the nature of the images formed in concave mirror and convex mirror, right? So now we are moving to the part 3 of our ray optics lesson. So in which today we will learn about Cartesian sign conventions, total internal reflection, importance of velocity and laws of refraction. Before we had learned the laws of reflection. Today we will learn about laws of refraction. Okay. First, what are Cartesian sign conventions? Cartesian sign conventions. Right. Now if you take a mirror, any mirror we take, whether it is a concave mirror or a convex mirror. Right? So now that mirror, one axis will run towards it. What is that axis name? Principal axis. Right? What is the definition for it? A line passing through a hole of a mirror. Right? So a line passing through it. So in a mirror, some adjustments or some assumptions we need to do. When we are doing sums based on this, or when we are making some calculations or measurements with respect to mirror, we cannot write down as it is. For example, if our temperature is 100 degree, right, in Fahrenheit I am saying, right, we are writing as it is as 100 degree Fahrenheit. But, right, here in this ray optics lesson, when we want to write the temperature, write the measurements, okay, we have to follow some rules, some assumption rules, some adjustment rules that are called as Cartesian sign conventions. Cartesian is nothing but you would have heard in the graph, right? Explain white plane you will have in the graph sheets. So that coordinate axis, x-axis and y-axis, that sheet, that area between x-axis and y-axis is called as Cartesian plane, right? And convention is nothing but in our practice, rules put into practice, right? So what are the adjustments we need to do in making a measurement in a mirror? Here that is what we are going to see now. First one, very important question, children. Surely this question will be asked. Okay. Number 1. And when you come to the class also, learn this and come. I'll ask in the class. Okay. Right. Now, whatever measurement you do with respect to a mirror, all those measurements should start with pole. It is a reference point. Okay. So, all the measurements to be done with respect to pole. What is pole? Pole is the center of the mirror. Okay. Right. Next one. If we want to measure to the right of the mirror, all the measurements will be taken as positive. Okay. That is what I call second point. Right. And the measurements we take upwards from this mirror, from the principal axis. Okay. That measurements will be taken as positive. Okay. So like in a graph sheet of which is simple. Right? Don't get this is x-axis, this is y-axis. Here x-axis is replaced by principal axis, y-axis is replaced by the mirror. Don't ask me, it is not straight, ma'am. You have to imagine like that. Okay? Right? So what is the second point now? All the measurements measured to the right of the mirror, right, are taken as positive. And all the measurements taken perpendicular above the principal axis, they are taken as positive. In your book, it will be given in a very, to your 7th standard level, it will be given in some of the difficult words. I will make that as a simplified notes and give you. Okay, so learn the notes, it will be easily understandable. Okay, children? Right. Now, all the measurements taken to the negative side, right, and the measurements taken down, they are taken as negative. So down is negative, left is negative. So third point is over. Right. Now when we study about the object size, always the object size should be taken as return has positive value. But when it comes to image size, right, we have two clarifications. If it is a virtual and erect image, see children, in your book always erect word alone will come. Right? Virtual images will all the time it will be erect. I have told you what is virtual image and erect image or real image, all those we had discussed in the previous class. Right? So when it is a virtual and erect image, the image size is taken as positive. When it is inverted image or the real image, the size is taken as negative. Clear children? Right. When it comes to magnification, magnification means what children? It is the, okay, I'll explain you like this. In concave mirror, we learned the image formation in a table column. No. In that we studied highly diminished, same size, enlarged, highly enlarged, we learned much children, we remember. Right. That diminished is, object will be in one size, image will be diminished. Then enlarged. Then highly enlarged, like that it is going. Size of the image in comparison with the object, whether it is diminished or a magnified image. That comparison, the image is double the size of object. The image is half the size of object. Like that we are comparing, no, object and image. That is called as magnification. That magnification value for virtual and erect image, it is taken as positive. For real and inverted image, it is taken as negative. And children, when you are doing like this, you will have some confusion. What is this? Positive, negative? All these confusions you will have, children. These are the rules we have to follow when we are doing sums. Okay, so first learn it. As we are saying it, accept it, learn it. When we are doing sums in this lesson, there we will apply this. Okay, so at that time you will get an idea why we had learned this. Okay, children. So fast recap I will give you here. Right and upwards are taken as positive. Left and downwards are taken as negative. And all the measurements will be taken over from the pole. And object size, virtual and erect. Object size is always taken as positive. Virtual and erect image is positive. Real and inverted image is negative. Okay, virtual and erect is positive and real and inverted is negative. For magnification, virtual and erect is positive, real and inverted is negative. So very important question. Okay, children. Now coming to total internal reflection. Have you ever seen diamonds? Right? Stone, glittering stone like jewelry ornaments. Right? So it would glitter. Have you ever seen children? So why that glittering happens? A diamond will have so many cuts. You can see in your book under this heading, total internal reflection. Due to that cuts, what happens to children? All the light rays will be reflected inside itself. Inside the diamond itself, it will be reflected. Right? So from one face it will come and hit on the other face, and from there it will hit back to the next face itself. All the light rays will be reflected inside the diamond itself. That's why that sparkling effect happens. Right? So now, when that reflection happens completely inside one medium, right? So that process is called as total internal reflection. Okay? So for this, what and all needed? There are some conditions to be done to get total internal reflection. First one is the light should travel from denser medium to rarer medium. What is denser medium? Right? A denser medium is one in which the particles are very close to each other. Right? A rarer medium is nothing but particles are very far apart together. For example, take glass medium, a glass. Right? When compared with the glass, light can travel very fastly in the air medium. But when it comes to glass, it has to travel very slowly. Right? So that the density of the particles decide whether the medium is denser or rarer. So this is your first condition. So the light should travel from denser medium to rarer medium. In what process? Total internal reflection. Then angle of incidence must be greater than a critical angle. Critical angle is represented by the letter I suffixed by C. Okay, I'll tell what is the critical angle is now. Now it is the angle of incidence for which the angle of refraction becomes 90 degree. In your book, under this heading, total internal reflection, down the page, there are 3 diagrams given. In that, 2 light rays are given. Are you following the diagram now? Just on the video, hear the content and see the picture. There will be 3 pictures. There one ray will be incident ray, another ray will be refracted ray or reflected ray. Yes, of course it is reflected ray, right? In that, in one diagram, angle of incidence is lesser than critical angle, angle of reflection, and in one diagram, and it will be greater than, and in one particular angle, angle of incidence will be greater than a critical angle. So there are 3 diagrams given. Less than it will be, equal to it will be, greater than it will be, right? So in that, in the third diagram only, all the complete reflection process happens inside. When that will happen? When angle of incidence is greater than critical angle. Okay, so what are the 2 conditions for total internal reflection? The light should travel from denser medium to rarer medium. Angle of incidence must be greater than critical angle. So this is the definition for it. But what is the critical angle now? It is the value of angle of incidence when the angle of refraction becomes 90 degree. For example, when I pass a light on a body, right, there will be some angle of incidence and some angle of refraction. Right? So now I have to change the angle of incidence so that angle of refraction becomes 90 degree. Okay? Till that value, that is, if the angle of refraction becomes 90 degree, what is the corresponding angle of incidence? That angle of incidence is called as critical angle. Is that clear, children? Right. Now, where we use this process? It is used in diamond and optical fibers. Diamond, just now I explained you, all the light rays are reflected inside itself. It won't come outside. That's why it sparkles or glitters. Right? But what about optical fibers? Optical fibers, children, nowadays is a very trending, highly scientific. Right? Now it is just like one tunnel, one glass tube. Simply I am explaining you. Right? In which it will be like one glass like wires will be there, through which signals can be sent. Now recently have you watched? Some villages are made to be connected through internet. Right? So that all will be done through optical fibers. It is just like a landline phone, right? So through that tubes, optical fibers tube, signals will be sent. So fastly it can travel. As because it is like glass-like arrangement, what will happen? Totally internal reflection will happen. So all the data signals will be sent and it will be reflected inside itself, and fastly it can travel. So now we are planning to get 5G network now. So that and all will be made possible through this. Right? So what is the process? Optical fibers. Right? Now we know the value of velocity of light in air. It is represented by the letter C. Right? So there is one formula which will connect the speed of light in air medium, frequency of light, and wavelength of light. I am telling you again. C is the velocity of light in air medium only. Right? N is the frequency of light. Right? Lambda. This one is called as lambda. Lambda is wavelength. Right? So why do we learn velocity of light? No. So based on that only these factors will be derived. What is the first formula? C is equal to N lambda. What is C? speed of light in air medium, m is the frequency of light, and lambda is the wavelength of light. Okay. Then we have second formula, this u, and it is extended at one side. This is called mu, mu, right? So that we call by a word called refractive index. How do we call it? Refractive index. That is equal to C by V. Right? What is C? The speed of light in air. Right? Just now I said. What is V? Speed of light in any medium except air. Right? So mu is equal to, mu is what? Refractive index, which I will explain now. Right? Refractive index, speed, C is the speed of light in air medium, V is the velocity of light, velocity or speed of light in any medium except air medium. Right? Now we have to learn only what about refraction. Already I have told you what is reflection, bouncing back of light back into the same medium. But what is refraction? When light travels from one medium to another. Have you ever seen children pencil when it is kept in a beaker, or when you keep your hands inside one bucket of water? You can see that it seems that our hand image is bent. Right? So that process, really do our hands get bent inside the water? No. It is straight only, but to us it appears to be bent. Okay, so that process is due to a process called refraction. It is bending of light rays on travel from one medium to another. What is this here mediums? The light is traveling from air medium to water medium. A bucket of water is water, right? Water medium, and through air only we are keeping the hands inside. So the light ray travels from air medium to water medium, right? Now what happens here? It looks like the light rays takes a bend. So that process is called as refraction. Even if in your water bottle, if you insert a pencil or a scale, it will look like it is bent from its path. So that process is called as refraction. Now similar as reflection, we have some laws for refraction also. The first one remains the same. That's why I didn't draw the diagram. Right? So one ray will be incident ray, another light ray will be refracted ray here, not the reflected ray. Refracted ray, clarifying diagrams I will give you in the notes. Okay. Here the same rule, first law has the laws of reflection. The incident ray, the refracted ray, be very alert to the word, and the normal at the point of incidence all lie at the same plane or same point. First line same. All the three things. What are the three factors? Incident ray, refracted ray, and the normal. All will be lying at the same point. Okay. Now second law, in laws of reflection we learn angle I is equal to angle R. But that won't be here. What we are going to learn here? Ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant. That is your law. I will explain that. This is a constant mu. What is called mu? I had explained here. Refractive index. Right? Here in refraction process, we have two angles. What are they? Angle of incidence and angle of refraction. In mathematics, student, there is one topic called trigonometry. I don't know whether you have learned it or not, but accepted what I am saying. In mathematics, there is a topic called trigonometry. In that we have three types of angles: sine angle, cos angle, tan angle. In that one type of angle is sine angle, right? So if we take sine angle of incidence and if divided with sine of angle of refraction, we will get one constant. That constant is called as refractive index. What is the symbol? Mu. How do we call it? Refractive index. So that is what we are going to learn now. It is the ratio of speed of light in two mediums. Right? Generally, how do we define the formula? Already I have written here, that I am writing here. Mu is equal to C by D. What is mu? Refractive index. What is C? Speed of light in air medium. What is V? Speed of light in any medium. Right. There are few other formulas you have. Right. Now what are they? This is mu 2 with respect to 1. Mu 2 with respect to 1. Right. Now how will you read it? Mu 2 with respect to 1. How do we read it? Refractive index of second medium with respect to first medium. That one other formula is excuse me children, it is V1 by V2. V1 is, there are two mediums we are comparing here now children. Mu 2 with respect to 1. Right. Now here speed of light in medium 1 and medium 2. So this is one formula. But how do you read it? Mu 2 with respect to 1 is equal to V1 by V2. Refractive index of second medium with respect to first medium is equal to V1 by V2. What is V1? Speed of light in the first medium. What is V2? Speed of light in the second medium. Now same thing we will write with the example of refractive index. I will get a chalk quiz for you children. Right. Now when it comes to refractive index, here we compare with the speed. Now we are comparing with refractive index. For this you will write as, when we go with refractive index formula, we will write as mu 2 and mu 1. Okay children, so what is the formula? Mu 2 with respect to 1, we have two formulas. If it is V1 and V2 means, if we are writing with speed of light means it's V1 and V2. If we are writing with mu means it is mu 2 by V1. Here every factor are same terms. Here this is also speed. C is also speed, V is also speed. V1 and V2 are speeds. Mu 2 and mu 1 are refractive indexes. They are same units, so their units will cancel each other. So refractive index will not have any unit. Okay, so we have learned the entire concepts till here. Finish the class work. We will meet in the class.